Hello everyone, this is Product Manager Fisher from RENAC Power. Thanks for your coming and giving me this opportunity to introduce our new product, energy storage systems to you. 3 years ago, RENAC Power's low-voltage energy storage system went to the market and was highly appraised and market-approved. Now, according to the new market demand and with cutting-edge technology, we have launched our new hybrid system, the high-voltage energy storage system. The advantage of this high-voltage solution is higher efficiency, smaller size, and more reliable. RENAC Power has two new residential ESS solutions. One is single-phase ESS solution. This system is ready for selling now. The other one is the three-phase ESS solution. It is under developing and will be launched in September. The battery cells we used are both from China's top 3 battery cell manufacturers. Turbo H1 series used Goshen High-Tech battery cell, and the Turbo H3 series used the CATL battery cell. This single-phase ESS contains Turbo H1 series high-voltage battery and N1HV series hybrid inverter. The capacity of one battery module is 3.74 kWh. Maximum 4 battery modules in one battery set, and 5 battery sets can be parallel. That means the maximum battery capacity can be 75 kWh, which is high enough for residential use. The power range of N1HV series hybrid inverter is from 3 to 6 kW. This battery system is made up by one BMC, battery mass controller, and several battery modules. The BMC can monitor the states of the whole battery system in real time and keep communicating with the inverter to control and protect battery system according to the real-time battery running states. The high-voltage battery modules are integrated with cell monitoring unit, keep sensoring the voltage and temperature of each individual cell, and passive balancing the cells during charge and discharge period. If you connect unbalanced battery modules in series, after few cycles, charge and discharge, they will be balanced. The N1HV series hybrid inverters apply to PV energy storage system with PV module, battery, loads, and grid. Here are the 6 core highlights of this system. Number 1, we offer 10 years complete system warranty because the whole system including hardware and software are independently developed by RENAC Power, so this system can perform better and more stable. This is our source of confidence to offer 10 years whole system warranty. Number 2, safety upgrade with world-class LFP battery technology. We are using vehicle-class long-life battery cells, so we can guarantee the performance. Number 3, tailor-made redesign friendly. We can do custom design on both our ESS and monitoring system. The monitoring system is also made by ourselves. Number 4, virtual power plant integrated. We have the ability to support VPP. Number 5, manufacturer local support. Our local team is ready to support our customers. Last one, super systems efficiency. 10 to 15% higher than 48-volt storage range. The biggest advantage of high-voltage ESS is high efficiency, which is quite obviously. Here are more features of the system worthy of mention. The first part is simpler installation and remote upgrade. Modular design, plug and play. For most of the connection cables, we already prepared for the customers, so the installation steps are very simple. Remote firmware upgrade. We can remotely upgrade not only the inverter, but also the battery. Only few manufacturers can upgrade battery remotely. The local upgrade is also quite easy. Using one USB disk to connect with the inverter can upgrade the whole system. IP65 outdoor design. The whole system can be installed outside. Second part is safer and more reliability. Safety upgrade with world-class LFP battery technology. Whole system tested and certified by TÜV Rheinland, Germany. The third part is great flexibility. 6 kW charge discharge rate. 150% off-site PV power, charge-discharge efficiency more than 97%. Integrated smart EMS supports various power applications. I will introduce the working modes later. Here is a comparison between high voltage and low voltage storage system. The first one is efficiency. High voltage storage system's efficiency can be 4% higher than the low voltage storage system. Second one is the circuit topology of the high voltage hybrid inverter is simpler. Size is smaller, weight is lighter and more reliable. The last one is with the same battery power. The battery current of the high voltage storage system is smaller, and the interference to the system is smaller. Below is a chart to show the loss difference between high voltage and the low voltage 10 kWh battery system. After 6,000 cycles working, high voltage storage system can save nearly 3,000 kWh than low voltage storage system. This diagram shows an AC retrofit system. Our storage system can work with the existing on-grid system, no matter what brand this on-grid inverter is. You can also install the N1 HV series hybrid inverter first and add batteries later. The batteries are also expandable. You can install one battery module at the beginning and add more battery modules later. This system also has the ability to work in three-phase grid, just using a three-phase meter to replace the original single-phase meter. Then this system can work according to the total three-phase grid power. For example, if there is 1 kW load on phase R, another 1 kW load on phase S, and 2 kW load on phase T, inverter will output 4 kW power to balance the total three-phase power. Next part is working modes. We have 5 working modes now. The first one is maximum self-use. This mode is applicable to the areas with low subsidies and high electricity prices. This storage system can store the solar generation in battery during the daytime and discharge battery to support load during nighttime. When the PV power is more than load power, rest power will charge the battery. If battery is fully charged or reaches maximum charge power, excess power will export to grid. Once the PV power is lower than load power, inverter will discharge the battery to support load. If the battery power is still not enough, rest of the power will be supplied by grid. The second working mode is thermal use, applicable to the areas with large gaps between peak and valley electricity prices. Customer can set time-based schedule to charge battery by app or inverter display. During charge time period, inverter will use the power from PV or grid to charge the battery. Outside the charging time period, inverter will work in maximum self-use mode, using the power from PV and battery to supply loads, and the rest part will be supplied by the grid. The third working mode is backup use. It is suitable for the areas with frequent power outages. Once the grid is off, battery is used as backup power to supply load. Under this mode, when grid is on, battery will be in charging state during charge time and will not be discharged. When grid is off, battery will be discharged to supply load. Inverter will connect grid automatically when grid goes back on. Next working mode is feed-in use. This mode applies to the area that has high feed-in traffic and export control. The PV generation will supply load first, then feed into grid. The excess power will charge the battery. The last working mode is EPS mode, applicable to the areas under unstable grid condition. When grid is off, during daytime, PV generation will supply load. Excess energy is stored in the battery. At nighttime, inverter will discharge battery to supply load. These are the 5 working modes we prepared for customers. The last part is the installation steps. Please watch the overview of the installation steps. This is all for today. Thank you again for your coming. See you next time.